snowy north.
It was a brutal walk today.
Oh, you walk?
Yeah.
Last time we
Ah.
took a cab, I'm like, why don't you take a cab last time but not this time?
Well, to those of you who are not here, welcome. Today we're going to talk about three important topics. DNS, the domain naming system. We're just going to do a local DNS server. We're not going out onto the internet and looking for .com or anything like that. We're just going to set up our own names, our own servers. And they're going to be Obi-Wan, Chewie, and we're going to set Obi-Wan up, and he is 192.168.10.254 as our DNS server. So that's the first important point I have to say is there's only one DNS server for the entire company, the entire network. Okay, so he's going to be our DNS server, so we're going to have to add the names of our servers. So we'll put his name in the data table. We'll put Chewie's name in the table. And we're going to add a couple more servers then to make it interesting. And this guy will be .253, and he's going to be Luke. And this guy is going to be 253 over on this subnet. And she's going to be Leah. So we'll have four names in our table, in our DNS table. So you're going to be given this, this lab again, this packet tracer file. Called dual LAN configured again. So to set this guy up as a DNS server, it's pretty easy. You just go services, DNS. And then there's two text boxes there that you can put data into. The name, so I'll put in Obi-Wan, and the address. 192.168.10.254 and add. And I'll do Chewie 192.168. Actually, I'm not going to put Chewie in yet because I want to show you what happens if the name isn't in the table. Okay, so that's the server. So this guy's all ready to give up the name Obi-Wan anyway. You know what? I'm going to add Chewie because services DNS. Luke and Leah aren't there yet, so I'll use them as the 99.254 is Chewie's address. So, oh, not DNS cache. Add. There we go. Okay, so I got Chewie and Obi-Wan in there. They're called A records, address records. They give the address of these computers. Okay, to set up a client, here's a client. We put in the DNS server address in the global config. So config global, which is what comes up by default. That's where our gateway is, right, for our computer. Right, the IP, the static IP for the computer is in fast Ethernet. But the global is where we put the gateway address, and that's where our DNS server goes. 192.168.10. And Obi-Wan is our DNS server, so 254. Okay. So now I can use names instead of addresses. So I could web browse to Obi-Wan, or I could ping Obi-Wan, and it will respond with Obi-Wan's IP. I can ping Chewie. Now the first ping will fail because we're going across the router. Hi. But the subsequent ones will be successful, and from now on will be successful. That works. But I can't ping Luke. Why? Well, I haven't put Luke on the network yet. Plus, I don't even get an IP for Luke yet. I could add Luke to my database, but I haven't added the server yet. Let me do that, just to see what happens. Luke, and his address is gonna be 192.168.10.253. So watch what happens when I ping Luke, even though he doesn't exist yet. So I get the IP address, right? There it is, 192.168.10.253. So I got the address from the DNS server. It's important that you understand what that means. That means I'm able to communicate with the DNS server, and he's got the name in his database, in his table. But it's timing out the ping because he doesn't exist. So I haven't put him in there yet. So anyway, that's DNS. Very simple. Just set up a table in the server, and hey, and set up a client to use it. So I'm just showing, you're going to be setting up DNS. So the way you do it is you pick your DNS server, and it's going to be Obi-Wan. He's going to be our DNS server for the whole company. You click Services DNS, and then you put these entries in the table. It's just simply put in Chewy and Chewy's address. That's 192.168.99.254. Luke is going to be here, 10.253, and Obi-Wan is 10.254, and I just haven't added Leah yet. Leah will be 99.253. And once you get those in there, then you can set up your client to use the DNS server, which I've done here by setting up an IP. See, under Gateway it says DNS server. I'll just show you where that is in config, global, gateway, and DNS server right there. Yours has been blank up until now. So once we add more PCs, everybody's going to be using that same DNS server. So there's one DNS server. So I make this only one DNS server because for some reason, I guess because of the nature of DNS, they think it has to be communicating between servers. No, we only have one DNS server in our company. And that's the only one that we're going to have. It's going to be Obi-Wan. So that's essentially part A of the lab. Part B is going to be setting up dhcp, the Dynamic Host Configuration Protocol. You got to remember about dhcp, by its nature, right, the four-step process. It does a discover. When a client wants to get an IP address, you turn the power on a computer, it doesn't have an IP address, unless it has a static one, but normally you set it for DHCP. The computer does a broadcast, says, hey, anybody out there got an IP address for me? That's a broadcast. That goes all around here, but it stops at the router. Like if this guy were asking for an IP, it stops at the router. So these guys have to have, each subnet has to have its own DHCP server. So we're going to set up DHCP over here on Obi-Wan, and we're going to set up DHCP over here on Chewy. So we're going to have one DNS server, but two DHCP servers, because DHCP uses broadcasts, where DNS does not. DNS uses an IP address, unicast, communicates directly. Like for DNS, this guy talks through the router and talks to the DNS server using an IP address. So, whereas DHCP uses a broadcast. Discover is a broadcast. Then the server responds with an offer. It's unicast. Then the client does a request. It's broadcast. And the acknowledgement is unicast. this is the DHCP four-step process for a client to get an IP address. He sends out a broadcast, says, I need an IP address. The server responds and gives you an offer. Now, I haven't set up DHCP yet. I will. I'll set it up. I'll show you now how to do it. It's pretty simple. So I'll set it up on Chewy over here on the right. So again, it's services DHCP. And all you have to do is type in the information that you want to give to your clients. First thing I guess we have to put in is the default gateway. Well, for every computer over here that I put onto this network, it's going to have this as the default gateway. So 99.1. So I'll do 192.168.99.1 is the default gateway for everybody over here. And the DNS server is 41. And you have to specify the starting IP that your DHCP server is going to start giving out. So we don't want to leave it at 0 because that's not a good idea. We're going to set it because it would give out .1 and it would be a conflict with our router. We're going to start at 100. I usually start at 100 for my DHCP IP addresses. And the subnet mask is the default there, it's fine. Now, I'm going to leave it off for now. I'm going to click save. This is one place you have to click save. Don't click add, click save. Don't worry, the lab tells you to click save. And I haven't turned it on yet, so it's not functioning yet. I'm going to switch this PC to use DHCP. So right now that PC's using static. Okay, that's a typical test question. What are the two ways for a computer to get an IP address? Well, one is static, where you manually put it in. The other one is through DHCP. So if I switch to DHCP, it's going to be yelling out, hey, any DHCP servers out there? And it's going to be listening, and nobody responds. And you get what's called this, I call it the bogus address. It's a 169 address. 169.254.x.x. There is a name for that address. Let's look it up. Google it. 169.254. What is, oh, there it is. 169.254 IP address. I typed it in yesterday. If the client is unable to find the information, let's read a little bit more about it. APIA is short for Automatic Private IP Addressing, a feature of Windows operating system. So this is a Microsoft thing, not Linux. Meant for non-routed small business environments, usually less than 25 clients. Well, what it is it's a Microsoft kind of thought that if they did this, it would make things better and make computers communicate better, but actually it causes problems. Because it makes people think that they have a valid IP address. But this address will not work. You won't be able to ping anybody on your network. You won't be able to ping outside of your network. So the address is useless. It's a bad idea from Microsoft, I think. But anyway, it happens. Actually, yesterday when I came into class, one of the students wasn't getting his desktop. He logged in, but he wasn't getting his desktop information. So I went over to the computer, I did an IP config, and I noticed he had a 169.254 address. What that meant was his cable wasn't plugged in. So his cable had come out of the back of his computer. So you get that address if your cable's not plugged in. So watch out for that address. It means DHCP is not working. It means you're not able to get an IP address from DHCP. Okay, so let me turn DHCP on now on the server. Services, DHCP, on. I don't have to click save. I will anyway, just in case. Okay, so now I go to the PC, and he's still got that 169 address. Oh, it refreshed. Or you can manually refresh, just click static and then DHCP again, and it will refresh and it will get its address. And there it is. It's got 101.168.99.1. 192.168.99.101. It's got its default gateway, 99.1. Best thing to do is to go into the command prompt like a real computer and go ipconfig/all. That's one of the steps the lab has you go through. And in that, you can probably hardly see that. You'll see there's the subnet mask, the default gateway, the IP address, the DNS server IP, all that information is automatically given to the client. Okay? So after you do that and you get it working, you will just simply take this PC and copy it and paste it, paste it, paste it 10 times, and you'll connect them up and you're good to go. Just plug them in and you'll appreciate how wonderful dhcp is, because you don't have to configure all those things. You don't have to configure, what are they? That's another test question. What does the dhcp server give you? IP address, subnet mask, default gateway, and DNS server IP. Those 4 things are automatically configured on these computers now. I'm most over it, and I'm getting the 169.254 address. It takes a little while for dhcp to kick in. I can go config static in dhcp, and I will now have an address. 103 I got. So this guy got 103, the gateway's there, DNS server's there. We're good to go. So that's what dhcp does for you. We're over here, they won't get an IP address. They'll get the 169 address because there's no dhcp server over there. They'll end up, like this. He's shouting out broadcasts. He's asking for a dhcp server, but nobody's answering because broadcasts stop at the router. So that's why you have to set up 2 dhcp servers, 1 in each subnet. And that's it. So I will, and then the third thing, so that's part B. Then part C, you're going to use a program called Wireshark. So you're going to be done using Packet Tracer at that point. It says, once you get to part C, it says, you are now finished using Packet Tracer for the remainder of the lab. So this is using a real computer. So on the real computer, you're going to type Wireshark. And up comes Wireshark. And it's a wonderful program. It lets you capture network traffic and look at it. So real network traffic on wires. You'll be able to capture it. No, I don't want the update. So the first thing you have to do is pick an interface. These are all my interfaces on my computer because of all the different software that's installed. VirtualBox, you guys use VirtualBox and all that. They all cause an interface. But the real interface is this one that says Ethernet. So that's the interface you want to double click on. And right away, it starts capturing traffic. And even with only 8 people in the room, we've got 3,422 packets already captured. There's a lot going on this network. A lot of it is broadcasted traffic, unfortunately. 7,000 packets. Anyway, so that's fine. It's capturing traffic. What you're going to do then is ping somebody. So you're going to ping somebody in the room. Let me see if I know any addresses. ARP-A shows you your ARP cache, and I can see on my Ethernet interface, oh, here's me. That's and that's another thing you're going to do is you're going to find out what is your own IP, what is your own MAC address, all this sort of thing. You'll be shown how to do that. My IP is 10.40.40.17. Looks like I don't have anything other than the gateway and the broadcast address here. These are just multicast addresses. We'll forget about those for now. So I need to communicate with you guys just so I can find out what your IP addresses are. So this is a tool we have Net Support School, and it communicates with all you guys. So now I know your addresses because I've communicated with you. Oops, I want to exit, yes. So now if I go ARP-A, I will see all your addresses here, 10, 40, 40, 25, 36, 43, 60, 61. Those are the people that have their computers turned on. So I'll just ping one of you guys. I'll ping 25, whoever that happens to be. Oh, and these are their MAC addresses, right? Or shows you your MAC addresses. They're all 1866 DA. Anybody know why they all start with 1866 DA?
Manufacturer.
Say again?
Manufacturer.
Yes, they're all Dell computers. That's Dell's MAC address there, 1866 DA. So I'll ping this guy, 25. So let me ping. Boy, I'm gonna have a lot of packets stored up. Ping 10.40.40.25. Get the 4 echo requests and 4 echo replies coming back, and then go back into Wireshark, and I've got how many packets? 58,000 packets. So I stop. Okay, so rather than paging through 58,000 packets, what you want to do is sort them by protocol. We want to sort them by protocol. And the way you sort something in a tool like this is you click on the heading, and it will sort it alphabetically. I don't know if you've started using Excel yet, but you'll learn how to do that in Excel and sort data. So then I go to the top, so I hit the home button, and then we go A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, I. When we stop at I is, oh, where's I? Oh, there it is. It's purple. I thought it was green. It's purple. ICMP. So these are my 4 echo requests and my 4 echo replies. So there's 8 packets there. And they're going between 10.40.40.17 in this column, and the destination is 10.40.40.25. So that's me, 17, pinging you, 25, whoever you happen to be. And you obviously can tell your computer's doing this in the background. You didn't get any message flashing on your screen saying, Mark Ellenberg is pinging you. Not like what they show on TV. Anyway, so that's my echo request, and then my echo reply is that coming back from 25 to 17. And for each one, so you click on it, and then you look down here, and you open up the Ethernet envelope, and you have a look, and you can see the source MAC address is mine, and the destination MAC address is yours. Okay, once you record all that information in the lab here, you'll record your IP, your MAC, your gateway, all that information. You'll say, oh, look at that. There it is, right there in front of my face on Wireshark. You're going to see your IP, your MAC. You're going to see your partner's IP and your partner's MAC. If you don't have a partner, ping me. How do you find out my MAC address? Well, you could ask me, but I'd rather you not. Just ping me and then do an ARP-A and you'll see my MAC address. So that's how you get my MAC address. Is you ping me and then you do an ARP-A, just like I did to find out your MAC address. Okay? And you'll snip that and highlight it and submit it in a Word document. And as well the reply. So this is the reply coming from you to me, your MAC address, my MAC address. You can even, you can look inside the ICMP packet if you're interested, and look at the stuff they put inside the ICMP data field. A, B, C, D, E, F, G, H, I, J, K, L, M, N, and then they have a blank, and then O, P, Q, R, S, T, U, V, W, and then they stop, and they restart over at A. And yours will be exactly like that, too.
That was this high.
And it says hi at the end. That's Microsoft, or whoever wrote this network stack program, the TCP/IP software inside of Windows, did that. Just to make you smile, I guess. So that when you're looking inside their ICMP packets, you're actually seeing the word hi. Secret message embedded inside of ICMP. So that's some of that stuff you do see on TV is actually true. They do embed stuff inside of the packets. So that's kind of neat. That's both the request and the reply both have that letters of the alphabet in them. Just taking up space. Kind of interesting. Anyway, so that's that. And then you're going to ping the college web server. So you do the same thing, but this time you're going to ping the college web server, which is not in this room. Not on our subnet. It's a different IP. I think it's 172 dot something. Pardon me. www.suecollege.ca. I can just do that. So you're going to ping www.suecollege.ca and catch the echo requests and the echo replies to and from the web server. Now, because it's outside of this room, outside of the subnet, right? You have to send it to the MAC of your default gateway. So you'll see the MAC of the college router in the Wireshark. Right? Because in order to get the packet out of this room, you have to deliver it through Ethernet to the gateway. So you have to use the gateway's MAC address as the destination. So the switch carries it to the gateway. Okay, so that's it. So I will open up the lab for you. If you have any questions, don't hesitate to ask. I'm going to actually put up some troubleshooting steps to help you if you have problems, because I don't necessarily want you to just ask me right away if it doesn't work. I want you to try to solve the problem, because that's what employers want, is they want people that can solve problems. So there's a couple of steps you can take to troubleshoot. So let me, I'll just put them up. We can talk about it for a second. CST 104 labs. Troubleshooting DNS. Well, it's actually troubleshooting DNS and DHCP. So troubleshooting DNS. So you ping with a name and it doesn't work. Well, are you able to, well, first of all, does the client have the correct IP address for the DNS server, right? 192.168.10.254 is our DNS server. First thing to check. Second thing to check, is the client able to ping the DNS server using its IP address? So like over here, am I able to ping the DNS server? Or did something get screwed up? Did you accidentally lose your static IP? And did you lose your gateway? If you lose your gateway, I'll show you how you can lose your gateway. Okay, let me close this. I'm going to open it up again from where we started. Packet tracer. File, open recent. Yeah, this will work. Okay, here's how you can accidentally lose your gateway. When you're using static IPs, if you accidentally click DHCP and then go back to static, you've lost your IP, you've lost your gateway, you've lost everything. So, here's a warning. When you're setting up your server, don't ever click DHCP on your server. The server, these servers must have static IP addresses, okay? So, one of the biggest mistakes students make is they click DHCP on their server. DHCP, this is DHCP client. No, if you do that, you're going to lose your static IP. And if you lose your static IP, you're dead in the water. So, your servers must have static IPs. They do not use DHCP as a client. Okay? So, there's a golden rule. Servers always have static IPs. So anyway, there's a little bit of troubleshooting steps. Is the DNS service turned on the server? So those are three basic things to check if DNS isn't working. Meaning, you ping with a name and you don't get an IP. Because that's what DNS works. That's really important that you understand. What does DNS do? You give it a name, it gives you an IP. That's it. Okay? That's what DNS does. Okay, and then DHCP, it's a little bit more troublesome because students can accidentally lose their static IP. And number one, troubleshooting DHCP, meaning your clients aren't getting IPs, they're getting 169 addresses. Does the DHCP server have the correct static IP address? Right? So if you lost the address here, you better put it back on and do it right, or DHCP is not going to work. And in the DHCP service configuration, make sure you didn't click add, but rather click save in DHCP server configuration. Okay, so that's why this lab today is critical. And I'm actually video recording the lecture and I'll post it on LMS for the people that aren't here. You guys are the ones with true grit. You made it.
Apparently. Shoveling.
Yeah, I know. Yeah, my girlfriend was panicking today. She had to go to on TV for an interview because she's part of the Bond Sue committee. And the driveway was plugged. I cleared it. Okay, anyway, I will put this up on the screen and I'll leave this troubleshooting up on the screen so that if you have problems, you just look up and say, okay, this is what I can